The event horizon, a cosmic boundary where gravity's grip becomes absolute, defines the point of no return for any matter or energy. Beyond this threshold, space-time itself distorts beyond recognition, directing all paths inevitably towards the singularity. For an object crossing it, the external universe continues its forward march, but its own trajectory is irreversibly altered. Within the singularity, classical physics collapses. A theoretical deviation proposes an ultimate inversion. What if, at this infinitesimal point, the very arrow of time reverses? Such a phenomenon would redefine causality for any object that penetrates this final, extreme region of space-time, challenging the fundamental fabric of existence. The conventional understanding of a black hole singularity describes an infinite density, a point where space-time curvature becomes unbounded. Here, all known physical laws break down, and the future ceases to exist as a navigable dimension. Objects are crushed, their constituent particles deconstructed into a timeless, placeless state. However, if time's direction inverted within the singularity, an entirely different set of dynamics would emerge. Instead of progressing towards inevitable decay, internal processes might reverse. From the perspective of an object within, the universe outside would begin to rewind, its events playing out in reverse chronological order. For an observer inside such a singularity, the light from distant galaxies would appear to retract. Stars would unform from nebulae, and eventually the cosmic microwave background would coalesce into the initial conditions of the Big Bang. This temporal reversal would present an impossible perception of cosmic evolution. The implications for information are profound. Instead of being lost or smeared across the event horizon, information entering such a singularity might theoretically be unmade. Particles would revert to earlier states, complex structures dissolving into simpler constituents as their causal history rewound. The precise mechanism for such an inversion remains hypothetical, unsupported by current general relativity. It would require an unknown physics, perhaps a quantum gravitational effect or a modification to space-time metrics that permits negative temporal flow, fundamentally altering the nature of cosmic entropy itself. Inside this hypothesized singularity, the causal chain would invert. Effects would precede their causes, meaning events might be undone. An object collapsing might uncollar its constituent particles, not into space, but deeper into the singularity's core along a reverse temporal path. Such an inversion of time poses severe challenges to the conservation of energy and momentum. If processes reverse, energy could hypothetically be unexpended or reappear from a future state, violating fundamental thermodynamic laws that govern the universe's forward progression and increasing entropy. The external universe would remain oblivious to this internal temporal gymnastics. From afar, matter would still be observed spiraling into the event horizon, its light red shifted into oblivion. There would be no observable reversal. The event horizon acts as a one-way membrane for both matter and temporal information. A time-reversed singularity would imply a decrease in entropy for its contents. Instead of increasing disorder, particles might coalesce, structures might form from chaos, and information would become more ordered rather than dissipate. This local reversal of the second law of thermodynamics is profoundly counterintuitive. The very concept of memory, rooted in the accumulation of past experiences, would be challenged. If time flows backward, an entity's memories might unform or revert, effectively forgetting its recent past and recalling an increasingly distant future from its inverted timeline perspective. The boundary condition at the event horizon would become a critical interface. Outside, time flows forward. Inside, it hypothetically reverses. This creates an unbridgeable temporal discontinuity, a cosmic paradox where entry represents an instantaneous flip in the perceived direction of universal flow. The future within this singularity would paradoxically be its own past. All paths would lead not forward in time, but backward, guiding objects towards the initial conditions of their existence. The universe's fundamental space-time geometry would become utterly alien, redefining the very concept of progression. In normal cosmic evolution, stars consume fuel and expand, galaxies drift apart, and entropy relentlessly increases. This forward march of time is an intrinsic property of our observable universe, dictating the progression from order to disorder and from cause to effect without deviation. Compared to terrestrial experiences, where even the most chaotic systems eventually succumb to thermodynamic equilibrium, A time-reversed singularity would represent an antithetical realm. It would be a place where the second law of thermodynamics is not merely paused, but actively inverted, defying all known macro-scale observation. For human perception, time is linear and irreversible. We age, memories accumulate, and events unfold chronologically. Inside the singularity, this fundamental aspect of existence would shatter. Aging might reverse, and memories could become premonitions of what? The very concept of a future within this singularity would be equivalent to its own past. Objects would not progress towards new states, but would revert to prior configurations. This contrasts starkly with all observable cosmic processes, which are inherently directed towards greater complexity or dispersal. Imagine a terrestrial analog, a shattered glass reassembling itself, or a fallen apple rejoining its branch. This mundane reversal, impossible in our universe, illustrates the profound physical paradox implied by a time-reverse singularity, where such unavitzes become the norm. The stability of atomic structures, typically maintained by predictable quantum interactions evolving forward in time, would be questioned. If time reversed, could atoms undecay, or could fundamental forces operate in an inverse manner, potentially creating matter from pure energy rather than releasing it? Such a system challenges the very notion of cosmic history. Rather than a universe expanding from a hot, dense state, this singularity would effectively experience a contraction towards its own local Big Bang. The external cosmic timeline would play out in reverse, witnessed only by those within this temporal anomaly. The stability of a time-reversed singularity is highly questionable. Such an extreme temporal anomaly would constantly contend with the forward-moving time of the surrounding universe. This immense temporal gradient could induce immense stresses, potentially making the singularity an inherently unstable, transient state. If a black hole emits Hawking radiation, what would be the nature of radiation from a time-reversed singularity? Would it be anti-radiation, effectively drawing energy back into the hole, or would it still emit particles, but with their quantum states somehow unevolved, defying conventional expectations? Should the black hole eventually evaporate through Hawking radiation, what would become of the time-reversed region? Would the temporal inversion eventually unravel, leading to a point where forward time reasserts itself, or would the singularity simply disappear, taking its reversed timeline with it? The fundamental conflict lies with the cosmic arrow of time driven by entropy. A localized reversal within the singularity would present a thermodynamic paradox. While locally decreasing entropy, it would ultimately have to reconcile with the universe's global increase in disorder, a reconciliation that is physically unresolved. Quantum gravitational effects at the Planck scale might offer a different perspective. At such extreme densities, the very fabric of spacetime could fluctuate wildly, possibly allowing for transient, localized temporal reversals. However, sustaining such a large-scale, consistent inversion within a singularity poses a significant challenge. The immense gravitational forces within a black hole ordinarily crush matter into an infinite density point. If time simultaneously reversed, would the matter uncrush itself along its backward timeline, attempting to expand but perpetually drawn back to the singularity by the overwhelming gravity? Alternatively, if the time-reversed singularity were to uncollobe, it might, in some exotic theories, manifest as a white hole, a theoretical region of spacetime that acts as a reverse black hole, ejecting matter and energy. This would be its own peculiar form of collapse, an outward explosion. The very fabric of spacetime, as described by Einstein, dictates a singular forward direction for time. A localized reversal within a singularity would necessitate a fundamental modification to general relativity, potentially involving novel quantum gravity theories or a breakdown of causality itself. Such a temporal anomaly would present an insurmountable barrier for any form of communication or interaction from the external universe. Information entering would effectively unsend itself, making any scientific observation or retrieval of data utterly impossible, sealing its secrets permanently. The concept clashes with the cosmic censorship hypothesis, which posits that singularities are always hidden behind event horizons, preventing direct observation of their exotic physics. A time-reversed singularity would be an even more extreme case of an unobservable, causally disconnected region. The long-term evolution of such a black hole would be perplexing. While its mass would continue to grow from infalling matter from the outside, forward-moving time, its internal core might be shrinking or unforming along its backward timeline, creating an immense, unresolved paradox. The fundamental particles themselves, governed by the Standard Model, would exhibit strange behavior. If time reversed, could particles uninteract, bosons unmediate, and fermions uncombine? The very forces of nature might operate in reverse, defying their established roles. The stability of the event horizon, a critical aspect of black hole physics, might also be compromised by this internal temporal inversion. The discontinuity between forward and backward time could generate instabilities, potentially leading to a chaotic, unpredictable boundary. Ultimately, a singularity where time runs backward represents a theoretical limit, pushing beyond the boundaries of current scientific understanding. It points towards physics unknown, where the most fundamental laws of the universe are not merely bent, but entirely inverted, a realm of ultimate cosmic paradox. The universe, in its grand design, operates under a set of fundamental rules, where causality and the forward march of time are paramount. These laws ensure a coherent narrative, from the birth of stars to the expansion of space itself, a predictable and ordered progression. The idea of time reversing within a black hole's singularity challenges this established order. It forces contemplation of physical limits, where the known universe ends and hypothetical realms of inverted physics begin, forever beyond direct observation and empirical verification. Such a theoretical construct serves as a thought experiment, pushing the boundaries of general relativity and quantum mechanics. It explores the deepest implications of space-time curvature and the nature of time itself in environments so extreme they defy comprehension. Humanity, observing the cosmos, recognizes the vastness and the myriad phenomena that govern celestial bodies. Yet, the singularity of a black hole remains the ultimate frontier, a theoretical point where understanding breaks down and the universe's most profound secrets might reside. Ultimately, whether time truly reverses within the singularity remains a profound mystery, a realm where even light cannot escape, and where the very essence of existence is redefined. What implications would such a reversal have for the initial conditions of the entire cosmos if echoes of it could ever escape?